Hi, thank you very much. Welcome for our usual YouTube tutorials. Today again I want us to look at how to use factor formula to integrate trigonometric functions. In the other episode, we looked at examples that had the same trigonometric ratios, a sine, and a cos. In this one, we are going to look at integration that involves a mixture of trigonometric ratios, that's a sine and a sine, of course. Then, in this case, when you have an integral that involves the multiplication of a sine and a cos, then your head must run so quick to remember the factor formula that involves addition or a subtraction of a sine. That is the one that will give you a mixture of a cos and a sine. Addition and a subtraction of a cos will give you similar trigonometric identities according to the factor formula. Now, to choose which one is appropriate for you to use, you will see actually the angle. When you look at this, a cosine as a 3x and a sine as an x. So you see a cosine has a bigger angle compared to a sine. So that means probably this cos of a 3x should have come as a result of addition. So that means this should have been because of adding alpha plus beta out of 2. And then obviously a sine which has a smaller angle should have been because of a subtraction. So that is why we have the cos having a bigger angle and a sine having a smaller angle. For this one, the sine should have a bigger angle and the cosine should have a smaller angle. So that means in this second example, which you are going to do yourself for your trial, a sine is 3 out of 2, which is 1.5x. It is bigger than 0.5x. So meaning, in the second example, you are going to use this first trigonometric, the factor formula, which involves a sine alpha plus a sine beta. But for the first one, because the cos has a bigger angle, we are going to use the second one, this one here. So let us see how we can solve this one using the factor formula. So, number one, we have that integral of cosine of 3x sine of x dx. That is what we are supposed to integrate. So I'll say from the fact that we have now actually settled that this is the right factor formula we are supposed to use, depending on the angles. So I'll have the sine of alpha minus sine beta gives me 2 of cosine alpha plus beta out of 2, and then the sine of alpha minus beta out of 2. This is what we have. So what I'm going to do, I'm going to divide both sides by 2 to make this one half. Open the brackets, sine alpha minus sine beta. This will give me cosine alpha plus beta out of 2, and then sine of alpha minus beta out of 2. Now, from this step, we are going to carry out a comparison. I want to make this similar to this, and how do I make that? By only carrying out a comparison between the two, this and this, so that we can solve for the values of alpha and beta, and when we replace them back to this, we shall have this looking like this. So, we are comparing cosine of alpha plus beta out of 2, and then sine of alpha minus beta out of 2. We are comparing with cos of 3x, then sine of x. We are comparing the 2. So, this implies that I will have alpha plus beta out of 2 being equal to 3x. When I multiply both sides by 2, I will have that alpha plus beta is equal to 6x. Can call this equation 1. Also, we will have that alpha minus beta out of 2 is equal to x this time round, implying that solve for alpha and beta. And so we are going to solve them simultaneously. So I will have equation 1 minus equation 2. On subtraction, I'll have alpha plus beta equal to 6x, and then I'll have alpha minus beta equal to 2x. On subtraction, I'll have that alpha minus alpha is 0, beta minus negative beta is 2 beta. And this is 6x minus 2x is 4x. And then this implies that my beta becomes 2x on dividing both sides by 2. Similarly, equation 1 plus equation 2. On adding them, we will have that alpha plus beta equal to 6x. And then I'll have also alpha minus beta equal to 2x. On addition of the 2, we shall have this is 2 alpha. This beta plus negative beta is 0 will take me to 8x. And so on division, that implies that alpha will give me 4x. So we will have that beta is 2x and alpha is actually 4x. So we can come back and replace for alpha and beta back here. So that implies that I will have a half sine of alpha. The sine of alpha is 4x. Minus a sine of beta. My beta is 2x. Sine of 2x is actually equal to cosine of alpha plus beta. 4x plus 2x divided by 2. That is 6x divided by 2, you get 3x. Then sine of alpha. Alpha is 4x minus 2x, you get 2x. Divided by 2, you get x. So that is what we have. So you see that the whole of this is just equal to this. So therefore, integral of cosine of 3x sine of x dx. When you integrate this, which is just the same as this, it's the same as integrating a half, because the whole of this is this. The same as integrating a half. Sine 4x minus sine 2x dx. So I can have this as integral of cos 3x sine of x dx is going to be a half integral of sine 4x minus sine 2x and this one dx. So on integrating, this will be a half. If we are going to integrate a sine of 4x, when I differentiate this, I get 4. I get its reciprocal, then it becomes a quarter. When you integrate a sine, you get negative cosine of 4x. Then minus, when you differentiate this, then this is 2, get its reciprocal, that's a half, times a cosine, but of course when you integrate a sine, you get a negative cos of 2x. Of course, plus c, which is arbitrary constant of integration. So this one becomes negative 1 out of 8 cosine of 4x. Then this one becomes plus a quarter, 1 out of 4, which is a cos of 2x plus c. So this I can alternate and it becomes 1 out of 4 cos 2x, then minus 1 out of 8 cosine of 4x plus c. This actually becomes our integral of cos of 3x sine of x, actually not 2x, the x will give us this. So that is how it makes it so simple. So for the second number, use the first factor formula, follow the same procedure until you get the correct answer. Thank you so much for following.